Hello friends, in this talk we are going to be talking about troubleshooting in a deadlock that we confronted in an Apache open source library. So that's what we're going to be talking. So feel free to interrupt and ask me any questions at any point in time. So this Apache library is called as PDFBox. So it is the library which is used to build or work with the PDF documents from your Java application. So this application ran into a deadlock. So that's what we're going to be talking about. So first, in our previous sessions, we have spoken about what is a deadlock means, but here we'll just briefly touch upon, right, what is a deadlock, and then we will see how this application was suffering from this deadlock. Okay. But if you want to see the more detailed deadlock conversation, you can go to the link which is going to be given in this description. Okay. Okay. So friends, first, what is deadlock, right? See, I want to illustrate this with a very practical, real world example. So say there is this two trains, right? There's two trains. They're starting from two different endpoints. Say this train is starting from here, left side, and then the train B is starting from the right side. So, but they started on the same track. There is only one train track. They both started on the same train track. So as this train progresses, and when this train progresses, what will happen, right? When they come closer, this is what we will end up having. So train both will come and meet each other, and the train A will not be able to progress. Similarly, train B will not also be able to progress. Why train A is not able to progress? Because train A is expecting the track where the train B is now positioned, right? On the other hand, train B wants the track where the train A is positioned, right? So both of them are holding a resource, and they want another train's resource, right? Due to that, it wouldn't be able to progress further. So that causes a deadlock, right? So this is a real world example of a deadlock, right? So now, see, sometimes, so now let's look at a programmatic example, right? A programmatic example which will cause a deadlock, right? So this is an sample program which will cause a deadlock, right? So friends, let's look at it. Here, this program is from a Buggy app. So Buggy app is an open source software which is capable of simulating various performance problems. So one such problem it can simulate is a deadlock. So this is a source code from it. Let's look at it here. Let's say there is this thread A, right? There is this main method. Here the thread A is started, and then there is another. Let me make it a little bit bigger so that it may be easy for you guys to see. Yeah. Okay. So there is this thread A which is getting started, and thread B which is getting started. So let's see what the thread A does. If you see thread A, what is it doing is the thread A, the run method, it is trying to invoke method 1 on a cool object, right? And here, let's see what does this cool object does. The cool object method 1, what does it do? So here is this cool object method 1. If you see, this method is a synchronized method, right? What will happen if a method is synchronized? Does anyone want to say in the call what will happen if a method is marked as synchronized?
Only one thread can execute that method.
Correct, exactly.
At a time.
At a time, exactly. So if a method is marked as a synchronized method, on this cool object instance, only one thread will be able to enter and execute this method 1, right? That's what will happen. So, and now when it comes here, this thread sleeps for 10 seconds. And after sleeping for 10 seconds, what does it do? It goes on to invoke method 2 on the auth object. Right? It goes on to invoke the method 2 on an auth object. So let's look at the implementation of the auth object. If you see the auth object, once again, this method 2 in this auth object is a synchronized method. That means only one thread will be able to go and execute this method, right? And what is the implementation of this method? This method is just doing a sleep. It's also sleeping for 10 seconds. And after that, it's going to invoke the method 1 of the cool object. Yeah, do you see? Method 1 is also a synchronized method, and method 2 is also a synchronized method. That means only one thread will be able to execute, right? So the flow of thread A is it comes, it first invokes the cool objects method 1, and then it goes on to invoke the method 2 of the auth object. Now let's look at the flow of thread B. See, thread B is also getting started. So what does the thread B does? So here, if you see the thread B, it first goes to invoke auth objects method 2, right? It's trying to invoke this method 2 first. And then what does this method 2 does? The method 2 goes on to invoke method 1. See, you guys want to try to visualize this a little bit, right? So here is how that visualization looks like. See, if you see this thread A acquires the cool objects lock first. That is, what does it do? Because now the thread A comes first, it goes to its method 1. It acquires a lock first because there is no one invoking the method 1, right? And then it is sleeping for 10 seconds, right? While this thread A has come to method 1 and sleeping for 10 seconds, what would happen to thread B? Thread B would have started, and thread B is now saying it's invoking the auth objects method 2. So thread B would have come here, this auth object. No one is invoking this method 2 right now at this point in time. So he would be able to go inside this method 2. Once he comes in, then he is going to sleep for 10 seconds. Okay. So now thread A is sleeping here for 10 seconds in method 1. And now thread B is sleeping here for 10 seconds. After 10 seconds it slept, what will happen? Now this thread A will try to acquire method 2, will try to execute method 2. Will thread A be able to execute method 2? No, it wouldn't be able to execute method 2 because thread B is still executing this method. Right? It hasn't completed it. It is still executing this method. So it will be put to the lock. It cannot progress. But let's see what will happen to thread B. Now the thread B is going to wake up after 10 seconds sleep, and then it's now going to go and try to invoke method 1. So will it be able to execute method 1? No, it will not be able to execute method 1 because the thread A is there. It is executing. Because as per the contract, a synchronized method means only one thread can execute that method at any given point in time. So it means both the threads are locking each other. They aren't able to progress forward. So this is a classic deadlock situation, right? So this is what a deadlock means in any middleware applications means, or any Java application or .NET or any such platforms. This is how the deadlock happens. Okay. So equipped with this knowledge, let's come back. So what was happening was this application was suffering from a deadlock. So what we did, we captured the thread dump, right? See, especially whenever a thread dump, whenever any deadlock happens, see, as per this one, it is due to the code, right? It is due to the threads. Sorry, let me repeat. Whenever any deadlock happens, it happens because of the threads, right? It's happening because of the threads. So when you want to diagnose a deadlock, what you want to do is you want to go about capturing a thread dump, right? So you can capture a thread dump using the tools like a JStack or JCMD kind of a tools. In the description, we will give what are the options to capture the thread dump. But what you will know that you want to capture thread dump only if you know it's a deadlock. But what we feel is only the symptom. The symptom is application is going unresponsive. An application can go unresponsive for several reasons. Maybe there is a garbage collection issue. Maybe there is a memory leak. maybe there is a network connectivity. It can any kind of thing can happen. So in that circumstance, what you may look at doing is you can use this yCrash data script, right? So this is an open source script. So when you trigger this script, the script is capable of capturing 16 different artifacts from your application, right? It captures entire stacks artifacts, 360-degree data, so that you can analyze all of them, right? So you can use this option as well. So once we captured, we took the thread dump and then we uploaded to the thread dump analysis tool called as a fast thread. When we uploaded, here you can see it is showing right at the top. This application is suffering from a deadlock. Here are the threads which is causing the deadlock. So you can see it is reporting that. Now, here you see this is that section. This has multiple sections. This thread dump analysis report. There is one section called as a deadlock. So here it is reporting. So this thread is in deadlock with this thread, right? You can see it is reporting. And if you see this thread stack trace, right? Look at this. This is the thread stack trace. It started out. It's coming along. It is executing this PDFBox code, right? It is coming through this PDFBox code, and now it is saying it has acquired this lock. It has acquired the lock on this object called RAF data stream. Okay. And after acquiring this lock, it goes on and it says it's waiting to acquire this lock, true type font. Right. So this is what this thread, first thread, does. But on the other hand, the second thread does the exact opposite thing. Look what it's doing. This thread also started out. Now this thread obtained the lock of the true type font, right? This is the lock what this guy is waiting for. The first thread is waiting for true type font. After acquiring that, it went on. It says now it's waiting to acquire this lock, RAF data stream. Right? So it has gone here and says it's waiting to acquire. But this is the lock which the first thread has acquired. So you see now there is this classic deadlock happening. Right? Any questions on this so far what I have shown? Okay, so I assume there are no questions. So then let me progress forward. So since this it confirms it is originating from this PDFBox, which is this Apache library, which is meant for working with PDF documents, right? So then we went and we are looking in this Apache Foundation's bug database for this PDFBox to see whether any such deadlocks were reported, whether were we running on a older version. But apparently we couldn't find anything. So then we went ahead and then we filed this ticket with them, saying that this is a deadlock, and then they can look at the stack trace. So, and then once we published, so they immediately acknowledged, thanks for detailed trace, it's a bug, they acknowledged immediately. And then they gave the fix for it, right? So it was very good to see the fix. They made it, in fact, very quickly, very almost in very few days, they were able to release, right? It is very good. So then once we got the upgraded version, then this problem went away. Right? So this is an kind of an overview of how we went about troubleshooting a deadlock in an Apache PDF open source library. Okay. Any friends on this, friends, that you guys want to bring up or discuss? Or is it making sense? Or any questions? Okay, I assume there are no questions, and thank you very much for watching this video.